All right there, folks, Mr. D. In this video, we are going to continue our discussion on periodic data. Remember, periodic data, periodic patterns are patterns that repeat over and over and over. They oscillate between a low point and a high point, back to the low point, back to the high point. On the previous night's worksheet, you were given, here is the answer key if you want to pause the video or full screen it, do what you got to do. Those are the solutions. If something's not making sense, please let me know. And now let's get into some vocab. New term for today is amplitude. Now the amplitude is going to be half the difference between the max and the min. I like to think of it using something called the midline, we'll get to in just a second. If you're a formula fan, if you want to calculate the amplitude, you're going to take 1/2 times the difference of your high point minus your low point. 1/2 of that big difference. Your midline is exactly what it sounds like. It's the line that cuts straight through your periodic function. Straight through your periodic function. If you ever need the equation of a midline, again, if you're a fan of functions and formulas, your midline is going to be half the sum. You're taking the average of your max and minimum values. Since the midline is a horizontal line, it always has to be written as y equals a number. Now, I like to think of this kind of visually. So what I like to do is take a look at a graph and I'll say, okay, my midline here is at 1 on the y-axis. The high point is at 3. The low point is at -1. So we have the midline here. We have the max up top, the minimum down below. When I think of the amplitude, I think how many steps do I have to go up to go to 3? And that number better be the same as the number of steps I have to go down to get to -1. That distance between the midline and the max or the midline and the min is the amplitude. So in this case, my amplitude is 2. My midline is y equals 1. Okay, so your midline cuts through the middle of a function. Your maximum is the high point, minimum is the low point. Amplitude is that distance between. Amplitude will always be a positive number because we are talking about distance between two quantities. You'll never have a negative amplitude. All right, let's take a look at an example. I want the amplitude of this periodic function. What is the equation of the midline? Okay, so my maximum is at 4. My minimum is at, let's see, that would be a -2 because we're counting up by 2's. So this would be a -2 right here. What number is smack dab in between those? Well, that number smack dab in the middle would be a 1. So my midline occurs at 1. So right there-ish. Now the amplitude is going to be the distance from the midline to the max or the midline to the min. How far away is that? Well, that would be 3. Doesn't matter which direction you go. It's going to be 3 for each one. So my midline, y equals 1. My amplitude is 3. Let's take a look here. More graphs. What's the max? What's the min? What's the amplitude? What's the midline? All right, so the highest point I hit, it appears to be at 1. The lowest point is at -2. Smack dab in between a -2 and a +1 would be a -1/2. So now we need to know what is the distance between those. Well, you could use those formulas as we discussed before if you're a formula fan. 1/2 of 1 minus -2 or 1/2 of 1 plus -2. You could do that. Or you've got to think of this logically out, right? If I'm a -1/2, I'd have to take 1.5 steps to get to a +1. So my amplitude would be 1.5 or 3/2. That's the same distance to go each direction from the midline to the min to the max. So my min, low point, my max, high point, was 1. My minimum was -2. My amplitude was 1.5, 3/2. My midline was y equals -1/2. All right, let's take a look at number 2. Got to be careful here because we're counting up by 2's. Always be keeping an eye out for these axes. So this is 2, this is 4, which means this would be 3. So my high point is 3. My low point is 0. Well, that's the min and the max right there. Then the midline would be smack dab in between. And then the amplitude is the distance, how far from that midline up to 3 or from that midline down to 0. Well, what's halfway between 0 and 3? And then chop that in half to get our amplitude. Oops. So our amplitude is 1.5. Our midline also happens to be y equals 1.5. Number 3, the maximum value appears to be 4. The minimum value appears to be -4, which means smack dab in the middle of those two, we're right at 0. The amplitude then is how far up do I go or down from the midline to get to the min, to get to the max. So for this problem, we know the max, we know the min, and then we can use that to find amplitude and midlines. Here we go. Number 4, we have another one where we're counting up by 2, so let's make sure we're careful there. My maximum is at 2, my minimum is at -4. My maximum's at +2, my minimum is at -4, so my midline is smack dab between those. Once I know my midline, I can get the amplitude by saying how far up from the midline do I go to get to the max, or how far down from the midline would I go to get to the min. Doesn't matter how you think of it, you'll get the same result. So our midline would be at -1, right, because -1 is smack dab between these. If you're ever confused on the midline, you can always take the average of these two values, so 2 plus -4, chop that in half. Your amplitude would be 3. Again, if you're a fan of the formula, take the difference of these two, chop that in half. So 2 minus -4, 2 plus 4, chopped in half. Those formulas, in case you didn't get them and want them, are right here. If you're a fan of formulas, there you go. All right, now let's get to sketching. We want to sketch 2 cycles of a periodic function with the given period, amplitude, and midline. Okay, so here is how we're going to do this. We're going to sketch out a vertical axis. From that vertical axis, we are going to plot our midline, which is at 6. So I'll put at y equals 6, a nice little dotted line. I'm going to use that for reference. I've got an amplitude of 4, so that means I'm going to go up 4 and down 4. So if I went up 4 from 6, I'm going to be at 10. If I went down 4 from 6, I'm going to be down to 2. Once I have my y-axis kind of handled, I'll throw the x-axis in. Now the x-axis has a y value of 0, so I just need to know in reference to everything else, where's the x-axis going to go? And it's going to be down here. Now the x-axis is where we label the period. If this thing repeats every 2, we can call it 2 minutes, 2 seconds, whatever, I'm going to have some repeated pattern that occurs over and over and over and over. Now I can choose whatever the heck pattern I want to choose. It just has to repeat. My suggestion to you is do something easy. I'm a big fan of just making a V shape. Okay? You can do whatever you want though. You can make some crazy squiggly thing. As long as you can repeat that over and over, go for it. But I would keep it nice and simple, make a little V shape, or kind of flip that upside down, make a peak. But whatever you do, it's got to start and end at each period marking. So there we go. I actually drew 3 cycles there instead of just 2. Let's see another one here. We have period of 6, amplitude of 3, midline of 5. So I'm going to start off, I'm going to draw the y-axis. My midline is -5. My amplitude is 3, so from -5 I'm going to go up 3, I'm going to go down 3. If I go up 3, I'm at -2. If I go down 3, I'm at -8. So that's kind of like my boundary lines for the function. Once I have my y-axis set up, I can figure out where's my x-axis going to go. Well, the x-axis has a y value of 0, so it's going to happen like right up here. This is where my x-axis would be. If the period happens every 6, that means every marking on the x-axis will be a multiple of 6. And I need to create some function that oscillates between the min and max and repeats every little interval here. So again, I'm going to go ahead and just make a little V shape. So there's one pattern. Now I'll have to duplicate that over here. I could duplicate that again. There's my periodic function. Yours might look different. As long as it's the same pattern over and over and over, you're fine. All right, home stretch here. To wrap things up, you are going to use the y values of a function to determine amplitude. Because remember, amplitude is the distance between the midline and the min, or the midline and the max. So as long as you know the middle, you can figure out the amplitude by going from midline to the max or midline to the minimum. Your x value determines the period of the function. How long does it take before something repeats itself? Let's see, error analysis. A student looked at the following function and wrote that the amplitude was 2, like a hooligan. Describe and correct this student's error. So it looks like the maximum value here is 2 and the minimum value is 0, which means the midline is 1. Well, amplitude by definition is just the distance between the middle and the max, or the middle and the min. So the amplitude should actually be 1. My guess is that this student, like a hooligan, went the distance from the minimum to the max, which is not going to be the amplitude. Last problem, think about it. A wave has a maximum of 6, and its midline is at y equals 1. What's the minimum? Let's see. If I think of this, I've got max, mid, min. The max is 6, the midline is 1, and we're trying to figure out what's the minimum. Well, I can use what I know about amplitude, can't I? To go from the midline to the maximum, that amplitude has to be 5, which means this would also be 5 down here. Well, that being said, my minimum would be -4. All right, that wraps it up for this video. You know the drill. If you have any questions, please do not hesitate to let me know. And as always, folks, good luck, have fun, be safe, roll Tide.